From our single table query section, we learned that doing select star from employee does two things. Number one, select star shows all fields. From employee chooses the table. Since there's no where condition, the from gets to show all records from the table. If we add a where clause after the from clause, we can limit the number of records we see. In this case, saying where location ID equals 1 limits half the records, and we only get 6 of our 12 records in our result set. If our equal sign is looking for a very precise match, it's possible that your where clause can have a condition so specific that you only get one record in your result set. In this lab, we're going to explore the use of more criteria possibilities that come after your where clause. We're going to explore more operators than just the precise equal sign in finding the matches you're looking for. Here's another example of a very precise piece of criteria that comes after your where clause. If I'm going to select all employees where the first name is Barry, I get one record. Now, I know there's more than one employee whose first name starts with the letter B. So if I erase everything after the B and run the query, I get no records because the equal sign is looking for an exact match. In other words, everybody whose name is B. However, if I change the equal sign to a less precise operator called like, and then I say B, it still doesn't work until you put what's known as a wildcard. The percent sign can mean any number of letters and any type of letters. Let's execute. And notice you get Barbara and Barry. If you understand that the percent is a flexible way to find any number of characters and any type of characters to look for patterns, but you're wondering what's meant by an equal sign as a precise operator and the like is an approximate operator, look at these two queries. We're going to start off with first name equals single quote B percent single quote and run it. And you'd expect to see Barry and Barbara, but you get nobody because the equal sign is looking for a name exactly B percent, and nobody has that name. By changing the equal sign to a like operator, we get the results we saw from just a few moments ago. This wildcard trick can be used with other letters too. Let's look at all of our employees first. We have 12 employees. Now we have some employees who have the first name starting with the letter E, and we could easily look through and see who they are, but let's have SQL Server tell us. Put where, first name, like, single quote, E, percent, single quote, and execute your query. And you see we get one result, Eric. Now we don't have to just start with a letter. We can choose to find everybody ending with a letter. For example, how many employees end in the letter Y? In this case, we will put the wildcard first because we're looking for any letters that finally conclude with the letter Y. Execute the query, and you get Barry, Terry, and Sally. Other names that could appear if it was in your database could be Joy. Let's take it a step further. Instead of starting with a specific letter or ending with a specific letter, let's look for a pattern anywhere in their name. For example, how many employees have a double R anywhere in their name? All you would do is percent, double R, percent, and execute the query. You get Barry, Terry. Now this next one is a borderline trick question. Let's say I'm looking for people who have an A in their name. Percent, A, percent. Now here's the question. We have somebody named Alex who starts with the letter A. We have somebody named Barbara who has an A in the middle of their name. And we have somebody named Lisa who ends with the letter A. Will Barbara appear because she's the only one with an A in the middle of her name? Or will Alex appear because there's an A in his name? Will Lisa appear because her name ends with the letter A? Well, what does the % wildcard mean? It means 0, 1, or any number and any type of characters. So make a prediction. Run your query. Notice we get Alex. Why do we get Alex? Because this % sign represents 0 characters before it found an A. Barry, well, it represented 1, and then it found an A. Lisa, it found an A and then no characters after it. The % sign represents 0, 1, or as many characters as it needs to find the pattern. Now this might sound like a word riddle, but what if you wanted to find everybody who has the letter A somewhere after the first letter? In other words, no Alex, because he has an A in the first letter, and no letter after the first letter has an A. Barbara, second letter is an A. Yep, we'll take her. Lisa, the last letter is an A. Yes, we'll take her. So we want to force it to find any letter for the first letter, and then an A anywhere after it. So what we're going to do is use the underscore. The underscore is similar to the % wildcard. It looks for any letter, but it's exactly 1 long. Now that we've ensured there's at least 1 letter, we want to look for an A anywhere else after the first letter. So we will go %, A, %, and execute. Notice we don't see Alex, but we see Barry, who has the second letter, Lisa, the fourth letter, Barbara, Sally, and so forth. You can use wildcards, and you can use many wildcards together. For example, we learned that A % finds all of the last names, like Adams, that start with the letter A. If I wanted to find all the names that start from A to B, I can put or, last name, like, single quote B %, single quote, and run it. And you'll notice in the result set, we have all the last names where the first letter ranges from A to B. How about A through K? Well, we can continue this pattern. Run this query, and you will notice you get a range of last names from A through K. There's an easier way to do the same thing. By using just one criteria statement, put a square bracket before the A, a hyphen, a K, and you get a range. Now, what's between the square brackets represents 1 letter. So 1 letter ranging from A to K with a % sign, single quote, run it, and you have a much easier way of achieving the same thing by using a range. So if you like ranges, there's another type of range query we can do. This one will go against the grant table. Notice grants come in varying amounts from $4,700 to $41,000. If I'm looking for grants that are greater than $20,000, I can do this, where amount greater than $20,000. Run it, and you'll notice you only get the grants that are more than $20,000. Well, what if I was looking for the results between $20,000 and $25,000? I can say and amount less than $25,000. Let's look for an expected result before we do this. It seems we have 1, 2, 3, 4 grants between $20,000 and $25,000. But only 3 showed up. $25,000, I've used the less than. If I want to change it so it's inclusive, we can put an equal sign here and an equal sign here. Run it. And now you get all of the numbers between 20 and 25,000. There is an easier way to do this. If you say amount and the word between 20 and 25,000 and run it, that's essentially the same thing. Using the between with the and is inclusive. In other words, 25,000 is considered to be between 20 and 25,000. while you're learning SQL Server, and one of your friends or coworkers who's known for being really good at SQL Server asks you, "So what have you learned so far?" See if they know this trick. Let's start off by doing something fairly simple and looking for all of the last names that start with the letter O by going O% and running the query. Now, why did they run this query? Perhaps they ran this query because they were looking for O'Malley, O'Shea, O'Shanahan. The intention of this query could have been looking for Irish names that start with the letter O and then have an apostrophe. Well, we did find 2 Irish names, O'Neill and O'Hare, but we also found Osako, which is not exactly an Irish name. So there's a pattern we're after here. O with an apostrophe. Well, an apostrophe and a single quote are the same thing. So if I put a single quote here, this is looking for an exact O, and this thing off to the right, this % with a single quote, looks like an error. SQL says, hey, I got my 2 single quotes, there's an O in it. I don't know what this thing is off to the right. So what are we going to do? The first apostrophe needs to be our first delimiter of our string. The last apostrophe needs to be the ending delimiter of our string. But that middle one should not be a delimiter at all. It should be a regular apostrophe. The way to do this trick is to put a second apostrophe after the first apostrophe to disable its special meaning. And now we get the O apostrophe names appearing. Let's use an example from the grant table. Type in square brackets grant because grant is a keyword. Hit execute, and we notice quite a selection of different grants as our result set. We have % signs, we have @ signs, we have apostrophes, and you can use all the tricks that you know to find the patterns you're looking for. Well, what if we're looking for email names? Now, my email name is probably different than your email name, but they have something in common. All email names have an @ sign in them. So a first attempt to look for email names might be this, where grant name, like, single quote, % at, % single quote, and run it. Are all of these email names? This is an email name. This is an email name. Now, how can you tell that at last you can help is not an email name? Email names do have an @ sign, but they don't allow any spaces. How do we find all the names with an @ with no spaces? Add and grant name, not like, single quote, % space, % single quote, and run it. Notice there are no spaces. We still have some entries that are not valid email addresses, but we're going to leave a little bit of challenge for you in the upcoming skill check to figure that one out. Time for Lab 2.2 Skill Check 1. You're going to write a query on the current products table of the JPro Code database. You need to display a result set of all records that have the letter X somewhere in their product name, like Mexico. When you're done, your screen should resemble the figure you see here. Turn to your book in Lab 2.2 Using Criteria and proceed to do skill checks 2 through 8. With that practice under your belt, you're ready for the ultimate challenge. Turn to skill check 9. Imagine that you've been asked to create a result set from the JPro Code database. You must create a record set showing all grants that were funded by somebody with a valid .com email address. To succeed, you need to use wildcards, and here's the logic you got to use. You got to find an @ symbol somewhere in their name. The email address should end in .com. Make sure there is at least one character before the @ symbol, at least one character after the @ symbol, but before the .com. Also ensure there are no spaces in the grant name. When you're done, your screen should resemble the figure you see here. That finishes up Lab 2.2 on using criteria. Next up, go ahead and dig in on Chapter 3.